Alrighty. Thanks everyone for joining. Let's get some locations in the chat. Where are people calling in from? Stockholm, Seattle.
Got in India. It's late, awfully late night. Thanks for calling in there.
Sweden, Poland.
Some good time zones on this. Where are you calling in from, Cole?
I'm calling in from San Francisco. I just moved up here about a month ago now, from San Diego, and yeah, I think it's great. The weather's been pretty good thus far.
It tends to be. It's one of the lovely place.
Alrighty. So who do we think is the furthest one calling in? I think India is probably the winner right
India.
now.
Yeah, I'm feeling India.
Local SF. Hi, Sammy from Nob Hill.
Uphill. Yeah, who's the closest?
Right, somebody's in my building.
New Zealand's pretty far.
Montenegro, huh?
Cool.
Alrighty, a question as well. How many people have deployed a background agent currently? Whether that's through an off-the-shelf provider, or whether that's through something you've hand-rolled. Curious of kind of where everyone's at in that journey.
While the chat rolls in, I'll chime in with my answer here. We've been using Devon a lot, and
Cool.
it's just been a fantastic experience. And I know what we're about to talk about here is heavily inspired by those like async background agents, and it's actually incredible to be able to fire these things off, have them triage. Live
Yeah,
kit
I
worker.
think, does LiveKit Worker count? LiveKit Worker would be through like voice, correct?
I think it is, yeah.
Interesting. But yeah, I think it's a pretty interesting shift. The analogy that I give is that it's very similar to going from like the ChatGPT coding flow to Cursor, where it was so obvious in hindsight that like this is how things should be done, and the capability increases not what you would expect, right? You would think that like, oh, what's the big difference between being able to spin this up? But as we'll kind of go through, I think it unlocks a lot of pretty interesting use cases.
And I think it's the ones that you expect less. It's not like necessarily a one-in-one replacement for working with your cursors or your Claude codes.
Yep.
I feel like it's able to answer a completely different set of questions. Got a modal user down here. Love that. Thanks for using us. What do you say, Cole? We wait another minute here and then we jump on in.
Yep, that sounds great.
Beautiful. Another question actually that could be interesting here for the chat while we wait. What size of company do you work with? Because I think that really influences the way you interact with these agents and like the scale of code bases they're working on.
Yeah, and to add to that, if there's any non-tech industries, I'd love to hear maybe a few of those of, using this in automotive or retail. I think those are pretty interesting non-standard use cases.
Mhm. We got Brian with 8.
Hospitals and clinicians. Fun employed.
Yeah. Vivek, I'm curious like any issues around PII and customer security when you're working on a code base like that. Because it's a pretty tight environment. Internal tooling, cool. Yeah, makes sense. I mean, that's the best way to do it is when the stakes are low and it's just something that I've heard it described, something that maybe you wouldn't have had time to sit down before. Now you suddenly have the ability to have all these internal tools that, previously would have just had, you'd have to live without. So I think that's a really cool use case. Enterprise mode, love
Alrighty.
that.
Eric, you want to kick us off?
Let's go for it. Go for it. Well, hello everyone. My name is Eric. I am an engineer at Modal. Here to MC this session, we have our guest Cole Murray. Murray, is that the correct pronunciation?
Cole Murray, yeah.
Cole Murray is joining us. Friend of Modal, founder of OpenInspect. He's going to be walking us through the entire process of building OpenInspect, motivation behind it, certain tips and tricks learned along the way, as well as how it connects to Modal sandboxes, other infrastructure providers that have been used, and really just like covering the journey of building one of these, and hopefully can answer your questions when it comes to if you want to do something like this yourself, how would you go out and do it? Could you build on OpenInspect? Could you work on your own thing? Uh, this guy is the guy to answer your questions there. Extra context about the project, the sandboxes side of this is run on Modal. Modal is a serverless container platform. We focus on functions, we do some GPU inference as well. We have Modal sandboxes, which allows you to execute untrusted code. And then I'll allow Cole to go into the other infrastructure details there, but we love having Cole on the platform. He's been a great guy to work with, and we're super excited to have him present this today. So Cole, I'll hand it over to you.
Cool. Thank you for the intro. A little bit about myself. My day-to-day, I run a consulting business, primarily working with seed and Series A startups, helping with everything from voice agents, coding agents, and more recently, a lot of background agent deployments. For the presentation today, I'm going to cover a little bit about why background agents are useful, some use cases for them, and lessons learned as I've deployed this across many different companies. With specifics to the format, I'm going to run through all of the slides end to end. We'll then pause and do some Q&A, and then there is a few demos at the end that we can then go through. Alrighty. So to set the context of background agents, I would say around December of this year, the release of Opus 4.5 and GPT 5.5, and as well as 5.3 Codex, created kind of a shift where a lot of people started to realize that these agents were quite capable of long-running tasks. And because of that, it started to create bottlenecks of running these systems locally. And so with that, in January, we saw a blog post from Ramp outlining their inspect system. We saw follow-ups from Stripe with their Minion system. We saw Coinbase release. And since then, the list has kind of continued on. And so there is a lot of interest in these background agent type systems. I'll break down more of what that is shortly. And a lot of teams are interested in deploying their own, but aren't necessarily sure how to do that themselves. And so we're going to cover basically what OpenInspect is, how we see teams using it, and some lessons that you can take away from this, whether you build on top of OpenInspect or building out your own internal system. And so to set the stage, we need to first kind of understand the localhost problem and why we're starting to run into issues with it. And so with localhost, most of us start off our journey. We are running one agent on one machine. That agent is then running its linting, its testing, it's creating a pull request after it completes. If you are running a language that is compiling, it then also is compiling that code. As your maturity and familiarity with coding agents grows, it is very common to then start running multiple agents simultaneously. Quickly, this creates a problem of how do we actually manage the state of the repository as well as the services that we're running. Most teams are using what's known as a Git worktree. The general idea is that we are creating a copy of the Git repo. It's not exactly a copy under the hood, but for kind of summarization purposes. This then is basically running a independent copy of that, and that exact same process of linters, compiling, that is all then running in these separate sessions. And so quickly this starts to break down because as our session counts are growing, most people are kind of settling around maybe 5 to sessions running simultaneously. Each of those sessions are then running linters, compiling all of that, and using a lot of the CPU and RAM of that system. And so if your laptop is not, a top of the line spec laptop, you start to begin experiencing slowdown and kind of friction with that machine. In more enterprise environments, this problem compounds because almost always you have a microservice type deployment where now you need to be running multiple copies of the microservices that you're running, each with their own independent databases and their own state. And quickly you kind of have chaos running on the machine. There's been a few projects, specifically one called Portless from, I believe, Vercel, which tried to address kind of the port assignment problem where because your dev server, let's say, runs on 3000, well, if your second work tree is running on 3000, then you have a conflict. And so there's a lot of solutions to kind of try to solve this locally, um, each with their own hiccups and problems associated. And lastly, a place where localhost kind of breaks down is non-engineers. Um, Expecting a PM or a customer support agent to be able to set up a developer environment and then maintain that environment over time is just not really practical. It's very difficult. It's not their expertise, and it's not really something that they want to be worrying about in their day to day. And so that kind of sets the stage of why localhost is an issue. And now we'll jump into background agents and what people are doing with it. So the idea of a background agent is that we're going to take that same local host coding session and we're going to move that into the cloud. Now, it most commonly is being run in a sandbox. That is not a requirement, but it is the most common way of running this. And the idea is that we want to take that same developer environment that we were running in each of those work trees and create a reproducible environment that runs in that sandbox. And so with that, we can then tackle several different use cases that we see teams tackling. Um, as a first example, we see a lot of usage around SRE use cases. The idea here is that whether you're using Slack to funnel your alerts, or Sentry, or Datadog, or any other of these tools, we can kick off a background session anytime an alert goes off. This in itself is a huge unlock because previously those alerts would sit waiting for a human to engage with them. That human would then start digging through logs, whether that's in OpenSearch or your log provider, and begin working to triage the issue. With a background agent, we no longer have to wait for that to happen. The agent can be instantly kicked off and begin investigating into this. On top of just being able to investigate and gather context, we can actually have the agent automatically fix the issue and create a pull request to handle that. And so with that, we can basically go from a alert going off to a completed fix within 5 to 10 minutes. And that in itself is huge. That is a capability that was only really possible, I would say, after maybe like December 2025, maybe a little bit earlier if you did harness engineering. But it's a very new capability that this type of system facilitates. The other very interesting use case we're seeing around background agents is the idea of empowering our support agents. And so a customer support team, most commonly, they don't have the knowledge and the SOPs to be able to tackle deep technical issues. With a background agent, we are removing a lot of the friction with doing that because the customer support can now directly tag that agent, whether that's in Slack, whether that's been built into their internal platform. And because that background agent has the context into the system, whether that's the logs, the production database, any of the other systems that we've connected it to, they're able to actually root cause the issue from the technical perspective themselves. And that is a huge win because in kind of a legacy world, engineering might receive a ticket from customer support that says, hey, the customer is trying to create a ticket and it doesn't work. In this kind of new world with a background agent, the ticket that arrives to engineering could be completely populated with the context of the logs and any of the other additional context. In a lot of cases, we're seeing agents actually able to resolve this completely without having to escalate to engineering. And I think that that's a huge win for customers as well as the customer support because they're able to resolve the issue for the customer without having a long engagement time for engineering to jump in the loop. A additional use case, which I see really kind of growing exponentially across teams as they roll out these systems, is PMs creating pull requests. In the previous world, a PM would create a document that would then get handed off to engineering. Engineering would then have to prioritize that into their existing backlog. And sometime later, that would then come up as a pull request. Because we've removed the friction of maintaining that developer environment, we now can have a PM creating that pull request themselves. Now, initially, this starts off with very small scope where maybe the PM is altering a line on the landing page or they are changing the color of a button. Um, all of those were not previously possible for a PM to do directly unless they had engineering experience. And with a background agent system, they now can directly tackle these. As the PM comes more familiar across what I'm seeing in deployments, the scope of their changes also continues to grow. They become more familiar with the system, as well as engineering, adding better tooling, better skills, prompt tuning, all of that to increase the chance of their success. And that's a huge win because the engineers, the PMs are not having to, create issues and wait for engineering to tackle them. They're actually able to be self-sufficient and create the pull requests themselves. A additional use case that I see a lot of teams working through that is a huge value add is just being able to perform on-demand data analytics. Previously, most companies that would require you to reach out to the data engineering team, a business analyst, and they would then take in your ticket, create a dashboard for you. With a background agent system, that's no longer required. The agent can directly generate the SQL, it can access the internal systems, and you're able to get on-demand answers to the questions you have. And so with some use cases out of the way, we will now cover what OpenInspect specifically does and how it fits into this background agent ecosystem. OpenInspect is built around the idea of one session with many services and many people. And so what that means practically is that that one session of the agent, a session in this case just being a prompt that was executed, the agent then goes and works on it. That can be accessed in many different surfaces. Today, this supports Slack, Linear, there's a web application, GitHub, and I see a lot of teams also building custom integrations into their own systems where they can now view it directly in internal tools. They've built Chrome extensions. Um, and just being able to have that same continuity across all of those surfaces, I think is a pretty huge win for teams. Additionally, because OpenInspect is multiplayer, we see a lot of use cases where the PM might start a investigation into an issue. They will then tag in engineering, and engineering can jump back into that session and continue through it. And this is a pretty big change because in that localhost world, there's not really a way to do that because that session is contained on your own machine. Where in a background agent system, anyone can contribute. We can all work on the same session. Somebody can submit follow-up changes. A additional capability of OpenInspect is that it has a AI code reviewer built in. The code reviewer runs on every pull request if you choose it to. The prompt is fully customizable, so you can guide the agent with whatever instructions you'd like. And additionally, you can mention the agent in a comment, and it will then address your feedback, create the commits if needed, and bring back up the changes. A pretty cool use case I see with a lot of teams doing this is that it removes the friction where a teammate has brought up a pull request. Let's say you've identified some comments, some things to change. Historically, you would wait for that teammate to then go and make those changes, and then you would re-review it. With the background agent system, because you don't need to set up that environment anymore, you can just tag the agent and it will go and resolve the changes for you. And so if there's a merge conflict, that can be auto-resolved, linting issues. And from a developer workflow, this is a pretty big win because we are increasing the velocity of changes that get merged in. The next capability is what we kind of outlined earlier, where the agent has automations. There is a few different automations that are supported. It can run cron schedules. I see a lot of usage for this for nightly bug bashing, daily reflection, where teams are automatically creating skills and linting rules. It supports inbound webhooks. So this is just a general webhook where any system you can now connect into this. It will take the payload of that system and then kick off a session and work on whatever you're asking. Similarly, it supports Sentry out of the box. There's a custom package for that, and it supports GitHub events as well. And specifically, I see teams kind of with some interesting use cases here, where they will create basically multi-agent code reviewers and give it specific instructions to look at, let's say, security or anti-patterns, with the idea being that we want each agent focused on its specific criteria. A new capability that just rolled out is the visual verification. OpenInspect can now take screenshots as well as recordings of the environment that it's working on. This is a huge win for teams, primarily in front-end use cases, where it is otherwise very difficult to verify that a front-end change is actually correct. The code looks correct, but with CSS, other things, does it actually work as expected? This is now supported. Similarly, a pretty cool feature that Modal offers natively here is tunnels. And so with that dev server that's running your local changes, you can now access that directly from the web application and actually click through the changes that you've made with a preview environment before you've actually merged this. And so now that we've got the use cases as well as some of the functionality covered, we'll dive a bit more into the architecture of the system. The system is built primarily on top of Cloudflare for the control plane. It uses durable objects, with each session having its own durable object and storing all of that session state in a SQLite database. The data plane here runs in Modal. Each agent gets its own sandbox. It lives directly in the sandbox. We'll cover a bit more of that shortly, but the agent is actually deployed within the sandbox itself. The harness is using open code. It runs in CLI. It supports custom tools, and there's a few custom tools that are built into the system. And then clients. It's supported across many different platforms, everything from web, Slack, linear, and it's very easy to fork and add support for this, as well as contribute directly. As an example, the linear support was added by an external contributor. Across the background agent systems that we've seen blog posts about, we see this general separation of the control plane and the data plane. This is just a very standard architecture that we're seeing, where we're storing all of the state outside of the actual sandbox, and then the sandbox itself is containing the environment. Within that sandbox, we are trying to perfectly replicate the developer environment as best as we can. Modal supports Docker and Docker, currently in alpha, And so I see a lot of teams using that where they will set up a Docker Compose and run all of those microservices within the sandbox. Um, I'd love to chat a bit more about this in QA, but there's a interesting discussion going on just around background agents as a whole, around whether the agent should live in the box or outside of the box. My kind of hot take on this is that I think that that is not necessarily the right framing of the discussion, because in any case, the agent is running in some type of container environment, whether that's a worker fleet that you have, whether it's in the box, the agent has to run some external process. And so I think that we should really be reframing the discussion around where the secrets are going, because that is actually the concern that we really have. And ideally, we want to isolate those secrets from the agent. With OpenInspect, there's basically two patterns where you can directly put the secrets in the environment, but there also is tools that call back out to the control plane. Specifically, there is a Slack tool as well as a pull request tool, with the idea being that the Slack token is never actually in the sandbox. And because of that, if the agent were somehow prompt injected or compromised, your Slack token is not accessible. Similarly, with your user GitHub token, that only lives within the control plane. And so the agent never has access to that. It is making a tool call to do that. A very common disagreement that I see with kind of the idea of background agents is that a lot of teams believe that it will be very slow, and that it will never be comparable to the local developer environment. Modal has a pretty great feature known as snapshotting, where the idea of it is that we're going to pre-build that developer environment. We are going to install all of the dependencies, pre-build the caches, run database migrations. Everything that we need to set up that environment, we can do ahead of time and then snapshot that state so that we can then restore from it. And so in a lot of cases, we actually see the opposite, where the background agent starts faster than you would in that local work tree setup because it already has everything installed. And so I think it's kind of just an interesting case where the background agent actually can be faster to start than your local environment. We covered a bit about this, but there's many different ways to interact with OpenInspect. I see a lot of teams, again, creating their own custom versions of this so they can support it within their internal platform. One specific piece that we didn't cover here, but I have a demo for at the end, is sub-sessions. So the agent can actually then create its own sessions. And there's some pretty cool use cases around this where let's say you have a large plan, you can then kick off the agent to take down the parallel parts of that plan and basically complete them all in parallel in isolated environments, which is a pretty neat functionality to have that, again, is not really possible in localhost. And so once you've deployed a background agent system, it does come with some initial friction that I think is important to be aware of so that you can plan accordingly. The background agent system is going to expose every gap that you have within your process. A lot of teams today, the developer environment is not actually reproducible. It requires you copying a configuration from your teammate. You then modify some of the file paths. You go and get the secrets from some other person. And every team member that onboards has to go through that. Background agents very quickly expose that because you will have to set up that environment to run for that agent. And so there is a lot of initial friction where you kind of have to sort out those issues and resolve them. A benefit, though, is that once you've addressed them, that sandbox is perfectly reproducible every single time. And so you only have to do this once. A similar issue that comes up that I see a lot of teams run into is that their access control within their systems, especially internal ones, don't necessarily have the best access control. And they rely a lot on just a developer using good judgment. In the case of a background agent or any kind of autonomous system, we don't really want to rely on, the agent following your instructions perfectly. And so this is an area that I see a lot of teams having to sort out once they first onboard with these systems. And so this is to be expected. I think it's good hygiene regardless, but I do see this as a initial friction point. The next area is building custom tools. The agents themselves are actually very capable, and if you have an API, they can figure it out very easily. But in a lot of times, it's kind of suboptimal, where the agent learned that it, let's say, first needs to list the endpoint, and then it will get a identifier and create a follow-up query. What we want to do with these systems is create custom tailored tools for them so that we can reduce the ambiguity for the agent and give it a very clear interface of how to interact with the system. Very commonly, I see teams wrapping their logging interfaces, their production database. A side benefit of doing this is that we can also control the context. In a standard case, we might receive back a API response, and there's 100 different fields that we probably don't care about. With a custom tool, we can wrap that, we can slim that down, and provide kind of custom query arguments on top of that that provide a tool tailored to the actual agent. And similarly, by doing this, we increase the probability of success of a task completing because we are refining how that agent trajectory goes over time, and we can make it a bit more deterministic. Lastly, a big issue that I see teams running into is that their existing systems are not easily verifiable. What I mean by that is that for the agent to be successful, we need a way to actually validate that the changes are correct. This could be in the form of integration tests, this could be end-to-end tests, but we need some way that we can actually verify that the code is correct. A big friction point that I see a lot of teams running into, especially with UI verification, is around authentication, where the agent does not actually have a way to log into the system. And so it will then try to start like editing the local files. It'll kind of reroute itself around the authentication. And the goal here would be that we should deliberately approach this problem and give the agent a way to bypass that local developer authentication so that it can verify the changes. Similarly, we see a lot of teams where they need to set up a seeded database that maybe they bypass that because the developers didn't need that, but it becomes a huge win for the agent when it has a reproducible and verifiable environment. A common question that I get is, how do you actually drive the rollout of this system? And so there's a lot of different opinions on it. I've seen teams where they will try to mandate it and say, hey, everyone needs to start using this. Customer support, this is your new kind of interaction pattern. In general, I don't see mandating working very well. I think kind of the right approach here is that we should make the system clearly better and not try to require it for every use case. As Eric kind of highlighted in the intro, there's very much still use cases that make sense for local first. I think especially in more kind of exploratory workflows, local does generally feel better. But similarly, there's also use cases where background agents are very clearly a better approach to the problem. A fun thing that is now supported first party within OpenInspect that kind of came from a customer use case was making adoption visible. There's now analytics that shows who's created sessions, how many they've created. And I think that this can be kind of fun because it helps one give a benchmark to others around how much people are using the system. It helps highlight who is kind of the power users of the system, who can then, whether it's leading workshops, whether it's helping others answer questions. I think in general, by making it visible how the system is being used, that in itself can drive adoption. And so, starting out, once you have the system, the general guidance that I give teams is start small with well scoped bugs, things that are very easy for the agent to tackle. The idea here is that we want to first iron out the actual system custom to your implementation. And so that might be adding new skills, that might be adding, let's say, a test driven development skill, because we learned that the agent was just not doing a great job of writing tests. And so by having very kind of trivial examples, we get to iron out those ahead of time. As you become more familiar with the system, begin delegating larger tasks. Most commonly, I see teams will create a plan locally with Claude Code or Codex, whatever they're using, and then they will paste in parts of that plan into OpenInspect and let the agent deliver that autonomously. And again, with that kind of sub sessions, you can actually have all of those run in parallel, which is pretty cool to see the plan being executed that quickly. And lastly, it's an ongoing system. I think there's maybe a misconception around kind of AI and ML systems that once you've built them, they're kind of complete. What we see across deployments is that after the initial deployment, the use cases are going to continue to grow. And so you'll want to staff up a team that can continue to support those new use cases. As an example, let's say that the data analysts are now using the system. Well, their queries are going to be very different from engineering's queries. And you'll probably want to add skills that help understand what tables are available in the environment, kind of nuances around your columns. All of that to say that the system is not a one and done system. It is a system that continues to grow as your organization grows with adoption. We'll skip over this one. And so after you've rolled this out, you're going to start having bottlenecks. You're going to have a ton of pull requests coming in with just the challenge of actually the human resources to review them. I think there's many different ways that you can tackle this. We can open it up a bit more in the QA, but some common patterns that I see teams doing is first and foremost, having an AI code reviewer. I think that whether that's with CodeRabbit, Greptile, using the OpenInspect one, having some form of a agent reviewing through this is a great addition because it can perform a first pass and identify issues that are obvious or that are otherwise subtle that maybe a human wouldn't catch. Similarly, the more that we can front load the correctness of the changes ahead of time before the pull request, I think is a huge win. I see a lot of teams addressing this with custom skills, creating custom linting rules to create back pressure on the agent. Git commit hooks are a great addition to this because we're forcing the agent to actually run the tests and kind of our checks before we get to that pull request stage. Lastly, a kind of more experimental idea that I'm seeing across teams is the idea of auto merging pull requests, with the idea there being that some changes are low risk, and in most cases, we can identify those ahead of time. And in those cases, we can just auto approve and merge the pull requests. I think each team's appetite for that is different. I've seen teams roll it out where if the change is under 50 lines of code, we're just going to directly merge it unless it touches, dangerous file 123. A benefit of a system like OpenInspect is that you can fully customize this and really design whatever rules make sense for you and your team. And so as mentioned, a big takeaway here is just giving the agent back pressure. The idea here that the agent works great in kind of a self-correcting loop. And so you should build tools and experiences that allow the agent to see its failures, correct on them before we get to that pull request. Here is an example of using semgrep. This is an actual example that I saw across my clients where basically the agent, for whatever reason, was trying to write manual raw SQL. And it's not always easy to directly address that. You can try putting it in Claude MD or your agent.md, but that doesn't mean that the agent is going to actually listen to it. And so they address this by using a semgrep rule, where basically if we see a pattern where the agent is trying to directly write SQL, it will directly fail the pre-commits and the agent will then have to go and correct that. And so three final lessons from this. The agent is only as good as your documented processes. As the agent takes on more use cases, expect that you're going to have to create new documentation, especially in cases where you have very large code bases. I see a lot of teams creating what I would call like a code map, which is basically the idea of like, here is where certain things in the code base go. Here's where you should look to solve certain types of problems. As mentioned, it's not a one and done system. Expect to continuously iterate on this, whether that's custom tools, skills, hooks, anything else. And lastly, plan for the operation load. As you roll this out across the organization, there is going to be a lot of demand on whichever team is maintaining this. And make sure that you're prepared for that. Make sure that they have time allocated to actually fix and improve the system. And yeah. And so the agent, it is a new hire. Every session starts brand new. Make sure that you're building context that allows it to not start brand new with each session. With OpenInspect, what things look like going forward. I think adding stronger support for sandbox primitives, everything from network policies, better access control, I think is a huge area of focus that I'm seeing across different deployments. Additionally, skills that grow themselves, the idea here of a self-improving system. I have a few active experiments going on with customers where we are using the automations to basically look at pull requests that happen every single day, creating reflections, and then using that to automatically create skills and rules to improve the system. And lastly, better access control. Right now, the system is designed for a single tenant and designed really that kind of anyone who has access to your code base should be able to work in it as they need to. As I'm seeing the system grow, I think that this is a interesting opportunity where we can potentially add better access control where perhaps certain team members may or may not be able to do all of the capabilities within the system. And so if you're standing up one of these for your team, I would love to chat. I do everything from advisory, kind of helping how you should think about the problem, to actually doing hands-on work, building out, whether that's that developer environment, custom tools, skills, and everything in between. And you can find me online at various different socials. And with that, we can open it up for QA.
We had a bunch of really great questions in there, but Cole, this was an awesome presentation. I really enjoyed listening to this, and I myself have a bunch of questions. So I'm excited for you to jump through the Q&A. Are you able to see it from your end?
Yes, let me pull it up. Alrighty, which order are these in? Okay, I'll start with the oldest one first, just since they came through. So question from Eric. As a portless alternative, how do you see Docker Compose working into this as a local alternative? And so I guess to make sure I understand the question is for teams running local agents, what is the best approach? How does Docker Compose work into that? Is that correct?
Yeah, this is actually my question, so I'll chime in. You were mentioning like the challenges of setting up agents locally, and I'm curious if you see these more declarative agent setups like Docker Compose in local setups, though I do know you later mentioned that people are using Docker Compose remotely with Docker and Docker set actually may answer the question already.
Yeah, specific to that Docker Compose, I see a lot of teams using that within the sandbox. As mentioned, Modal supports this. It's currently in alpha. And yeah, I think that that's a great way where you're able to use the work that you've kind of already done in that local environment and then port that directly into the sandbox. With that, I guess a caveat, with the pre-snapshotting, definitely make sure to pre-pull your images again, so we get that quick boot and we're not downloading them each time.
That's great.
Question from Eric again, does it support MCPs? Yes, it does. It supports local MCPs as well as remote MCPs. There is some active work for supporting OAuth MCPs as well. Um, OAuth is not currently supported though, so coming soon. A question from Vivek: how do we manage and track memory? If you're doing 1,000 PRs every week, there can be drift. So I guess the question is generally how to approach memory and context curation. I see automations as a great approach to this, where you can run scheduled jobs that happen nightly, weekly, at whatever cadence. Um, a great way of managing the context around that is prompting the agent to use subsessions for that, so that each pull request is getting its own session, and you're kind of isolating the context there. With that, you can then collect all of the learnings from that. And then at your choosing, you could create a pull request for all of those new skills and context refinement as well. But yeah, I think automations is a great approach to this. And that's what I see most teams doing today. As mentioned in the roadmap, it is something that I'm actively thinking about, of kind of how could we automate this process. I think there's a lot of interest in self-improvement. And so, yeah, happy to discuss more. Feel free to open an issue if you have any thoughts around it. A question from Vivek. So how do we prevent recursively damaging the whole code base? I think kind of the idea here behind this is maybe once the agent sees a bad pattern, how do we make sure that pattern doesn't get self-reinforced? Um, I see a lot of teams addressing this with linting rules. I think that that's a great approach, where you can directly identify the context. Similarly, I think automations are a pretty good fit here, where I myself, and I've seen across deployments, teams will run basically a dedicated automation that will look for anti-patterns or divergence between existing patterns. And I liken it kind of to like gardening, where you have to kind of maintain the code base. You need to clean out cruft that accrues. There's libraries for detecting dead code. I think Vulture is a very common one. But yeah, the short answer is that it is a ongoing maintenance task, whether that's humans writing your code or AI writing it. It's something that we have to do in refactoring and improving our code. Do you have thoughts on multi-repository sessions? Yeah, so this has come up actually a few times within the GitHub issues. I'm not totally sold on multi-repository sessions, at least in the idea where we're making changes across multiple repositories simultaneously. You can, as part of that pre-setup, clone multiple repositories and images. But a kind of challenge that I see, if you're making changes across multiple repositories, almost always those changes are going to be coupled in some way. And so you're creating a deployment risk by doing that, where if both of those changes go through the pipeline at the exact same time, one of them is going to land before the other and would not be compatible. And yes, you could try to design of, we always ship backwards compatible changes, but in general, it's kind of taking a lot of risk by doing that, because one pipeline could stall, or there's n many issues that could come up. And in general, I think it's kind of an anti-pattern. And so it's not currently supported. But in theory, yes, you could make the system do that in your own custom fork. The next question we've got. So I think this is actually the same question from Mike, kind of just the idea of like multi-repos. So I'll just skip over that one. The next question we've got from Lars around if I have a session and the VM stops, when I resume and the agent does not have any memory of the previous session. Yeah, so I think the question here is that after the VM has expired and basically gone away, how do we maintain the state of the system? With OpenInspect, it takes a snapshot after each turn, as well as a snapshot. If you had a long running session up to that timeout, it performs a snapshot just before that. And so the state of whatever the machine was in at that time is persisted. And then when you would create your follow up prompt, it will then resume from that state and basically have everything of the state that the machine was already in.
That's a good question.
Velocity of change seems quite high. How did you manage sourcing upstream changes for your clients? Any recommendations for maintaining itself over time? Yeah, great question. So the question is basically with a lot of changes going on, what is my suggestion to kind of downstream teams on how often they should be syncing and kind of a general policy of that? I think for each team, it depends on their own environment. I see most teams syncing from the upstream at least once a week. In a lot of cases, teams are running nightly automations to just pull in the latest changes. Um, in cases where teams have heavily forked their own, that does require a bit more customization on their part, where they, in some cases, have merge conflicts and have to resolve those. But in general, we try not to do any kind of like large sweeping changes that otherwise would be backwards incompatible. Where possible, we try to maintain compatibility. And so, yeah, in general, we see teams syncing in most cases nightly. And a funny part of this is that you can use automations to do this as well. And so the agent can, self-update itself and create the pull request to do that. The next question from Vivek, how do you manage global skills? I see this varying across teams. There is maybe a few different schools that I see going on here. One is teams maintaining a GitHub repo specific to their skills, which is basically just a collection of all of those skills. Within OpenInspect, there is a setup.sh script, which basically runs before the environment actually starts. And so in those cases, the teams are then cloning that centralized skill repo. It gets pulled into the environment, and the agent now has access to all of those skills. Related to this, there is I believe, an active issue within GitHub for this. I think it's an interesting idea of could we support this directly within the system? I am very interested to hear people's thoughts on like how they would like to do that. I think we could certainly store it within a database. We could provide kind of like an editor UI. It could maybe like create a GitHub repo through the system. Mostly looking to hear feedback from teams on this, but I think in a long-term roadmap, I could definitely see this being first-class supported within the system. We've got a next question from Julio. Should agents have a Yeah, great question, Julio. So the question is basically with the sandboxes, should they always be running or should they kind of be on demand, especially in cases of like GPU sandboxes? OpenInspect is designed to automatically shut itself down after 10 minutes of inactivity, with the idea here being that we want to save costs. We don't need that sandbox always running. And so just before it shuts down, it will snapshot its state. And then when you create a follow-up prompt, that state is directly restored. And so you're not, you still have everything that the sandbox was already in, other than the networking and anything that was in memory at that time. That said, Modal does, at least maybe Eric, you want to talk a bit more about this. There is a memory snapshot. And so potentially, yeah, go ahead.
No, I can speak to that. Memory snapshots are a fickle beast to get into. When and where possible, we recommend doing full direct or full file system snapshots because that it freezes the state in a safe way that you could safely reconstruct from later. We do support memory snapshotting, which allows you to freeze a running process, like literally freeze the RAM and then reboot that later. There's some sneaky bugs in that. For example, if you have timestamps in memory, later when you reboot it, those timestamps and the diffs start going off. Environment variables, things like that. We generally push away from it. Where that generally does benefit is on our inference platform, where you have model weights in memory, and pre or reloading those across sessions is more useful. So we support it. We generally don't recommend it unless you know what you're doing. And if you know what you're doing, go ahead.
Cool. Yeah, that's been my experience as well. That I don't see too many use cases other than the model weights you mentioned where you would want a memory snapshot. It does create a fair amount of complications. A use case that I saw was teams wanted to uh, keep basically an agent browser in memory so that they could then restore it. Um, in theory, that sounds like a good idea until the actual website that you're looking at is not, that is not snapshotted. And so what you're viewing when you come back is not actually the state of what that website is and any other resources. Um, and so OpenInspect currently does not support memory snapshots. Um, Maybe it will sometime in the future. Maybe that'll be an option, but currently it's just file system.
And if you want to make it lighter weight, we do support subdirectory snapshotting, so you don't have to full out snapshot your entire user environment. So there are ways to speed it up that doesn't include memory snapshots.
The next question we've got here, do you start a new sandbox instance per invocation? What determines the sandbox destruction after task completion? Yes, so each prompt, a new sandbox is created. Any follow-up prompts on that same session reuse that same snapshot, and that will continue indefinitely as long as you maintain that session. Um, Similarly with Slack, when you create a Slack thread, the session is maintained through that thread itself. And so as replies are going in, the agent can not only see all of those replies, but they all are working on that same environment. And then what determines the sandbox destruction? Basically idle time. If the sandbox sits, I believe the default is 10 minutes now. If it sits for more than 10 minutes, it will save its state and shut itself down. And that is customizable. There's a variable for that you can alter. Um, sure. Well, I'll just skip over this one quickly. But Lars, feel free to open an issue for this. Happy to take a look through it. The next one, do you see the line of work you're doing expanding as more companies OpenInspect FD? That's great. Yeah, so the question is basically, as more teams are rolling this out, do I see there being kind of increased, I guess, opportunity of people kind of deploying this on behalf of customers and helping them tune it? I think definitely, and just from kind of my own consulting, I'm seeing a lot of teams looking for that, where they want that expertise of somebody who kind of knows the system in and out, knows the problems with agents. I think in kind of the larger scope of just background agents as a whole, the problem is very heavy service dependent, especially because it is not a one and done system. You need somebody to be maintaining and updating the system over time. And whether that's internal or external, I think that's every company's decision. But I think it's very difficult to make a kind of one and done product here where everything, you deployed it and it works perfectly forever. I generally don't see that as the use cases grow.
And I'll jump in until such a role exists. Remember that Cole is available for technical consulting, and obviously he's the world expert at this topic. So feel free to reach out to him. Cole, do you have any contact info that you want to share on that topic?
I do, yeah. So on my personal website, it's just my last name, first name, murraycole.com. I have a Calendly there, as well as a email that you can reach out. In general, what engagements look like with companies, I have kind of two different types of engagements. One is pure advisory work that will typically be around 3 months. where I will work with the teams to set up tools, developer environments, kind of helping them iron out the journey through that. And then the other deployment is more hands-on, where I will work with teams to actually build this on my behalf, and I'll bring a team to help them set that up.
And I'll say from experience working with a lot of agent teams, Cole's really on top of this. I felt like I learned a lot during this presentation, and trustworthy guy. So hopefully I'll reach out.
Cool. We are just about at time, and so very quickly, I'll give maybe just a cool little demo of what the experience looks like for people. And so this is the Slack experience. Here I've just created a example where a user has kicked off a session. The agent will then spin up that sandbox. And oh, I went too fast. But as the agent is working through and emitting tool calls, you can see the stream as it's working through it. And then the last response from that agent will show up in the chat. And similarly, there's a link here where you can click on View Session. That will then take you to the web application, and you can see kind of the whole experience there. The next one that we've got. So this is what the web application looks like. Here we are just creating an example of creating multiple tasks simultaneously. And so if we look on our left-hand sidebar here, we just created 4 different tasks. These are all now running simultaneously in their own sandboxes. And kind of a cool benefit of doing this through the agent is that the agent is actually specifying the prompt to each of these subtasks, the same way as a local subagent would. And in many cases, that prompt is probably going to be better than the prompt that you and I would give, just because it's so much more comprehensive and has a lot more context than we otherwise would. And the last one, actually, I think there's one more, is the recording functionality. And so this is a agent who built, in this case, just slides, and then it recorded the session of that, so you can actually see the slides interacting. And then for the sake of just showing the example, I had it then reskin all of the slides to match the OpenInspect color scheme and create a new recording for that. And so this is very similar to the flow that a PM or someone might go through, where they create it, they record it, they don't necessarily like it, and then can iterate on top of it. And then the last one is linear. And so there is a linear integration where you can directly take your issues in linear and then create a session from that. And you do that just by tagging OpenInspect. There is a couple like labels and other fancy things within the integration, but at a high level, that's the most basic way to kick it off. And so here we can see in the activity that the agent is starting up. It will automatically classify the repository based on that issue itself. And so it uses a LLM to basically pick of the repos. It will then work through it. And then in this case, it created a pull request. And so kind of that idea of like a software factory where we can take an issue and go directly from issue to pull request. And I think that that's everything.
Fantastic. Cole, this was, again, super awesome. I really, really enjoyed sitting through this, and I hope the audience did as well. Again, it is murraycole.com in order to contact you, last name, first name. Y'all should work with him. And I believe, perhaps we can find it on this one. I believe we'll have a transcript or a video of this published in the future, which will contain links to all the materials. So everyone stay tuned to the mailing list and Twitter, and you should be able to see that come through.
Alrighty. Thanks everyone for coming out today. Oh, yep. Last questions. We'll take this one just because we didn't cover it as a fun one, and we can end here. So what do I see the vision for the future looking like? And I'll maybe give it as just kind of the broader background agents rather than specific to OpenInspect. I think it's clear from what we see in agents that they will continue to excel at long-running tasks. And in that environment, it makes less and less sense to have the
Are you all able to hear and see me? Right now, it looks like we had an issue with the stream.
let me chime back in.
There we go, cool. That was weird. We all got kicked out.
Weird. Where at what point did we get kicked out?
It was about 20 seconds ago, 30 seconds ago. We're talking about longer horizon tasks.
Okay. I'll just give maybe a short recap then. I don't know
Yeah,
how long I went into the little monologue, but
yeah.
yes, I think long running agents will continue. Um, I think we're already seeing very clear trends of that. And so if you're an engineer today, I would start thinking about not necessarily writing code, but how do we write systems that write code? How do we address the correctness issues? How do we build environments to where anyone, regardless of their skill, can contribute, whether that's designers, PMs, even the CEOs, somebody who maybe is not in the day-to-day of engineering, but wants to be able to contribute. Um, let's start thinking about those problems and how we will address them going forward.
Beautiful. Well, that's an excellent end to our live stream. Thanks again, Cole, for coming on. We really enjoyed this, and thanks, Felicia, for helping out backstage. Again, we'll be publishing this later, so keep your eyes out on socials and the email list. And Cole, thank you again. Thank you so much for doing this. This is a great time.
Alrighty, thank you so much.
See you.